The James Webb Space Telescope is identifying objects in the dark ages that, by best measurements we have, are large, fully developed galaxies. So who ordered that?
$900 trillion stars, gone without a trace. The James Webb Space Telescope, a $10 billion masterpiece meant to unlock the secrets of the universe, has stumbled on a chilling mystery. Entire galaxies, hundreds of trillions of stars, simply vanishing. No supernovas, no fireworks, just darkness swallowing light. Let us uncover the truth or face the horrifying possibility that everything we know could slip away into nothingness. Stars disappear without a supernova. Imagine this. You build a $10 billion telescope designed to peer into the far reaches of the universe, only to find things disappearing. The James Webb Space Telescope has made a discovery that has astronomers scratching their heads. We're talking about stars, 900 trillion of them, no less, vanishing without so much as a goodbye. Entire galaxies, simply gone. The truth might be more shocking than we imagine. It's hard to overstate how baffling this is. Just for context, the way scientists confirm the presence of galaxies out there is fairly straightforward. Gather a ton of light from one patch of sky, analyze it, and determine what's glowing and what isn't. This sounds easy, but in reality, it takes years of work and loads of data collection. Hubble has been doing this for ages, but Webb's infrared capabilities made it possible to see much further back in time, all the way to a period known as the dark ages of the universe. It turns out there's some real-world evidence for this theory. A project called VASCO, led by Beatrice Vaisala, recently discovered dozens of stars in old photos that just don't show up anymore. These stars literally vanished over the course of several decades. Could it be that some stars simply skip the explosion and go straight to the black hole stage? This theory is gaining traction, especially since astronomers recently found a bizarre star-black hole combo called VFTS 243 in the Tarantula Nebula. This system has a black hole without any evidence of a previous supernova, almost like it just snuck into existence. No fireworks required. If this turns out to be true, it could change what we know about the universe's recycling process. Supernovae are like cosmic composters, blasting all sorts of elements, oxygen, carbon, even gold, out into the universe where they can eventually form new stars, planets, and even life. But if some stars skip the supernova step and collapse directly into black holes, they're essentially taking all those precious elements with them. It's like the universe is getting stingy, hoarding materials that could have been used to create new worlds. There's something undeniably bleak about this. It's like the universe is telling us that time is running out, not for us as individuals, but for humanity as a whole. Our ability to explore the cosmos, to reach out and touch other galaxies, is being taken away bit by bit. Luckily, if the big rip is coming, it's billions of years away. We probably won't have to deal with it, but the fact that we even have to think about it, that we have to consider that the universe itself could just unravel, is a testament to how little we really know. JWST has already delivered some incredible discoveries, but it's also brought up more questions than answers. What is dark energy? Why are stars disappearing? Is the universe trying to tell us something? Maybe, just maybe, it's reminding us to look while we still can. The universe is changing, constantly evolving, and every second we waste is another second that something incredible might vanish forever. The stars we see today might not be there tomorrow, and the galaxies we dream of exploring could slip beyond our reach before we ever get the chance. It's a stark reminder that while the universe is vast, our window to understand it is not limitless. Think of the universe like a giant balloon. If galaxies are dots on the surface of that balloon, as the balloon inflates, the dots move farther apart. The galaxies themselves aren't moving through space. Rather, space itself is expanding. The consequence of this expansion is that eventually galaxies will be so far apart that their light will never reach us, no matter how powerful our telescopes are. In other words, they will vanish from our sight forever. This means that the observable universe is shrinking in a very real sense. Not in size, but in content. While the physical dimensions of the observable universe continue to grow, the number of galaxies we can actually see and study is dwindling. Each second that passes, more stars and galaxies cross the threshold of visibility, and they do so permanently. By the time light from these galaxies reaches us, they have already receded beyond any chance of us ever catching up to them. As we explore further, we find an even more troubling process changing what we can see and understand. Dark energy is stealing the universe from us. In the distant future, our cosmic neighborhood, the local group, will be all that remains visible to us. The local group is a collection of galaxies, including our Milky Way, Andromeda, and about 50 smaller satellite galaxies that are gravitationally bound to each other. While the rest of the universe drifts away, these galaxies will stick together, slowly merging over billions of years into a massive elliptical galaxy. Outside of this group, however, the rest of the universe will become unreachable, hidden behind an expanding curtain of empty space. This might seem like an abstract concern. After all, we're talking about events billions of years in the future, but it has significant implications for how we understand the universe. The fact that dark energy is causing everything to accelerate away means that the future generations of astronomers may not have access to the same view of the cosmos that we do today. They might not be able to observe the cosmic microwave background radiation, the afterglow of the Big Bang, or the distant galaxies that tell us about the early universe. In a way, we are living in a special moment in cosmic history where the universe is still largely accessible to our instruments. Fortunately, current measurements suggest that if the Big Rip is going to happen, it's at least tens of billions of years away. But the possibility remains a reminder of just how much we don't know about the universe. We know that dark energy exists, we see its effects, but we don't know why it's there or how it works. It's a profound mystery, one that will require new ideas and new discoveries to solve. One thing is certain, the universe is dynamic. It's constantly changing, and our understanding of it is evolving with each new piece of data. The James Webb Space Telescope has already shown us that the cosmos is more surprising and more mysterious than we imagine. It has revealed galaxies that seem impossibly old for their age. It has found strange alignments and odd structures, and now it has hinted at the possibility that stars, entire galaxies even, can vanish without a trace. These discoveries challenge our assumptions and force us to reconsider what we think we know. Are we missing something fundamental about how stars evolve? Are there processes at play that we haven't yet accounted for? The fact that stars might collapse into black holes without a supernova explosion suggests that there is still much we don't understand about stellar death. And if black holes are forming without the telltale signs of a supernova, what does that mean for the way we detect and study these enigmatic objects? It's not just the stars that are vanishing. The galaxies themselves are becoming harder to study. As they move away, their light becomes increasingly redshifted, stretching into wavelengths that are more difficult to detect. The James Webb Space Telescope was designed specifically to address this challenge. Its infrared sensors can pick up the faint, stretched-out light from these distant galaxies, allowing us to see further back in time than ever before. But even JWST has its limits. Eventually, the galaxies will be too far away, their light too faint, and they will disappear from our view forever. Our place in the universe is fleeting. We exist in a tiny window of time where we can still see and study the cosmos in all its glory. The fact that we can even observe distant galaxies in the afterglow of the Big Bang is a stroke of luck, a result of being in the right place at the right time. But that window is closing. The universe is disappearing bit by bit, and there's nothing we can do to stop it. The cosmos doesn't owe us anything. It's indifferent to whether we figure it out or not, whether we explore it or not. Galaxies will keep drifting, stars will keep collapsing into black holes, and dark energy will keep pushing everything apart. Our job as curious beings on a tiny blue dot is to keep looking, keep questioning, and keep wondering. Because in the end, that's all we really have, the fleeting chance to understand just a tiny piece of this ever-vanishing universe. The James Webb Space Telescope, JWST, was supposed to show us some breathtaking new images of the distant universe, maybe some star-studded galaxies we'd never seen before. Instead, it stumbled onto something nobody expected. About 900 trillion stars just poof, gone. Scientists are now scratching their heads so hard they're practically bald, wondering if maybe, just maybe, they've got some cosmic trickery afoot. Enter the multiverse theory. Level 1 is the most boring, just like ours but far away. A different starting point, same old physical laws. These guys won't be sending postcards anytime soon. Level 2 gets more interesting. Here, universes have their own unique rules and constants, formed like separate cosmic bubbles from the Big Bang. If we ever visited, gravity might pull sideways, or pie might taste like broccoli. Who knows? Then there's level 3 and 4. These are deep in hardcore theory territory. Level 3 involves every quantum decision splitting into new realities. Like if you'd chosen pizza instead of a burger, there's a universe where that happened, and one where you didn't. Level 4? Well, those are just straight-up math worlds. Better bring a calculator. Some scientists are suggesting, and I mean really stretching their imaginations here, that maybe these galaxies didn't just disappear like that leftover sandwich you were saving. Nope, they're hinting that these galaxies might have crossed over to another universe. Not a metaphor, not an illusion. Like for real, these galaxies may have hopped dimensions or whatever. And all Webb can do is wave them goodbye in infrared. Just when we think it can't get stranger, it does. Could black holes be leading us somewhere completely new? Black holes may lead to parallel realities. If there's anything that brings a good sci-fi twist into real science, it's black holes. They've always been the boogeymen of space. Gravity's so strong that not even light escapes. But what if they're also highways? What if all those stars that we see fall into black holes are not gone, but instead have taken a detour into a parallel universe? Webb's infrared eyes have noticed that some stars bypass the whole supernova explosion drama and collapse directly into black holes. Maybe those stars just skipped out of our universe. No goodbyes, no dramatic exit. And that's the fun thought, that black holes aren't just monstrous dead ends. They could be more like secret portals. Some scientists seriously think JWST is giving us hints of matter slipping away into those cosmic drain pipes and emerging somewhere far, far away, maybe in one of those bubble universes. Imagine that. A star collapses into a black hole here and pops out like some cosmic jack-in-the-box over there. But of course, theories are nothing without evidence, especially when you're talking about alternate universes and black hole bridges. The scientist's game plan here is to keep watching for things that shouldn't be happening according to the good old physics we know. Redshift changes, anomalies, galaxies that fade away with no reason, or weird gravitational behavior. Webb's got its infrared goggles peeled for anything that breaks the rules. The thing is, without conclusive evidence, we're all stuck here playing guesswork. And the multiverse idea isn't the kind of thing you just prove on a Tuesday afternoon. But the James Webb data keeps piling up, and one day it might finally give us a clue that's undeniable. Until then, those 900 trillion stars might just have taken a one-way trip through an interdimensional door. If you're not already in over your head, consider what all of this means on a philosophical level. If there really are other universes, that means our own universe is just one little piece in an unimaginably vast quilt. The laws of physics as we know them, they're not the be-all, end-all. Maybe our reality is just one room in a much bigger cosmic mansion, and sometimes the doors between rooms get left open. We're here, sitting on Earth, assuming everything out there's supposed to follow our rules, when in reality, we could just be a tiny part of something much bigger. And what's even wilder is the thought that these stars didn't vanish at all. They just moved to a different reality, where maybe they're being observed by someone else, equally confused about their arrival. As we zoom further into this cosmic mystery, it becomes apparent that the James Webb Space Telescope might be revealing more than just pretty snapshots of faraway galaxies. The JWST may well be unlocking a Pandora's box of possibilities that challenge everything we thought we knew about the universe. Let's dive deeper into how these missing stars might fit into an even grander cosmic mystery, layering theories upon theories. One such theory is the concept of quantum entanglement on a universal scale. Imagine that the stars or galaxies that Webb is witnessing are not simply disappearing, but are instead involved in some sort of cosmic entanglement. Quantum entanglement usually involves particles that, once linked, can seemingly communicate instantaneously across great distances. Well, some scientists wonder if the universe itself could have entangled properties. The galaxies we see could be intricately linked with something else, something in another dimension perhaps. When they disappear, it might be because their entangled partners have shifted, causing them to move as well. Then there's the concept of brain cosmology, a theory that suggests our universe is just a three-dimensional slice of a much larger multidimensional space. According to brain theory, our universe could be floating alongside many others in this higher dimensional space. When JWST observes galaxies disappearing, it could be that these galaxies are simply moving across these multidimensional brains, becoming invisible to us as they slip into a realm beyond our perceptual limits. Another tantalizing theory revolves around the idea of the cosmic web. This cosmic web is thought to be the large-scale structure of the universe, made up of filaments of galaxies separated by vast voids. Imagine it as an intricate web stretching across the universe. Now, what if this web isn't just a framework of galaxies, but also a bridge to other realities? Perhaps some of the stars JWST observed aren't vanishing in a literal sense, but are crossing over to sections of the cosmic web that overlap with another universe. This could create the illusion that these stars have simply walked out of existence. Some theorists call these crossovers ghost universes, parallel realities that brush up against our own, occasionally exchanging matter and energy. The missing stars may have wandered into one of these ghost universes, or perhaps even been tugged there by some unseen force. This interplay between realities could be a common feature of our universe, a natural consequence of the quantum foam that some scientists believe lies at the heart of all space-time. Another aspect worth pondering is the role of gravity in all of this. Gravity, as we understand it, is the force that governs the motion of stars, galaxies, and indeed the entire universe. But what if gravity is not just a force within our universe, but also extends beyond it? Some scientists think that gravity could be leaking into or from other universes. If that's true, then what JWST is seeing might be galaxies being yanked away by gravitational forces originating in these neighboring realities. Imagine a giant cosmic tug-of-war happening across dimensions. A galaxy that was comfortably nestled within the observable range suddenly gets an extra-dimensional yank, disappearing from JWST's view as if it were never there. These gravitational effects could also explain the strange, almost ghost-like behavior of some of these galaxies, fading in and out, visible one moment, gone the next. And it's not just gravity. The idea of dark energy plays a role here too. Dark energy, that mysterious force driving the accelerated expansion of the universe, could have properties we don't yet fully understand, properties that interact with other dimensions or parallel realities. Dark energy could be acting as a kind of cosmic siphon, drawing galaxies into hidden realms that JWST, with all its sophisticated technology, is only now beginning to hint at. The notion of disappearing stars also begs the question, could this be a signal of something more apocalyptic? Some scientists speculate that if these stars are truly vanishing into other dimensions, it could be indicative of a universal phase transition. Just like water turns to ice, the universe might be undergoing some kind of cosmic shift, transitioning into a different state of being. This phase transition could mean that certain areas of space are becoming incompatible with our current version of physical laws, causing stars to vanish as they phase out of our universe and into another. On the flip side, this could also signal a rebirth. Perhaps these missing stars are not disappearing in the destructive sense, but are instead being reborn in a different form somewhere else. If brain cosmology or the bubble universe theory holds any water, then what JWST is seeing might be a transfer of energy, stars being reconstituted in another universe entirely. This process could be part of a larger cosmic cycle, one that involves the continuous birth, death, and rebirth of celestial bodies across multiple dimensions. Could these stars be evidence of a reality beyond our own? Let me know your thoughts, and if you enjoyed this, don't forget to like and subscribe.